Today we're going to learn about parallel line proof. Parallel lines are coplanar lines that do not intersect, such as lines J and K.
Transversal line. A transversal line is a line that intersects two or more coplanar lines at two different points, like line F.
Now we are going to talk about transversal angle pair relationships.
Interior angles. They are the angles that lie between two transversals that intersect the same line, such as 3, 4, 5, and 6.
Exterior angles are the angles that are not between lines J and K, like 7 and 8 and 1 and 2.
Consecutive interior angles. They are interior angles that lie on the same side of transversal M, like 3 and 5 or 4 and 6.
They say if two parallel lines are cut by a transversal, then each pair of consecutive interior angles are supplementary. This turns out to be true because it's the consecutive interior angle theorem. Hence, look for C's.
Alternate interior angles. They are non-adjacent interior angles that lie on opposite sides of transversal M.
The theorem to this is alternate interior angle theorem. It's when two parallel lines are cut by a transversal, then each pair of alternate interior angles are congruent. A tip: to find the alternate interior angles is to look for a Z.
Alternate exterior angles. They are non-adjacent exterior angles that lie on opposite sides of transversal M, such as angle 1 and angle 8, angle 2 and angle 7.
When two parallel lines are cut by a transversal, then each pair of alternate exterior angles are congruent. Sorry, but there is no hint for this one.
Last but not least, there are corresponding angles. Corresponding angles are angles that lie on the same side of transversal M and on the same side of lines J and K, such as angles 2 and 6 or 3 and 7.
Corresponding angles has a postulate instead of a theorem. It is when two parallel lines are cut by a transversal, then each pair of corresponding angles are congruent. Tip: look for the letter F.
Now let's do a proof. The given will be line J is parallel to line K. We'll prove that angle 1 is supplementary to angle 7.
Now we already know that J is parallel to K for the given, so let's go on to the second one. So number 2 would be angle 1 is supplementary to angle 3. The reason would be that linear pairs are supplementary. The third step would be the measure of angle 1 plus the measure of angle 3 equals 180. And that's the definition of supplementary angles. Then the fourth step would be angle 3 is congruent to angle 7. That's because parallel lines give you congruent corresponding angles.
For statement 5, the measure of angle 3 equals the measure of angle 7. That would be the definition of congruent angles. Number 6 is the measure angle 1 plus the measure angle 7 equals 180, making this substitution. Finally, angle 1 is supplementary to the angle 7, which is definition of supplementary angles.
Now in the real-world application. Lenape has decided to add more parking spaces to the senior parking lot.
They want to make sure that the new addition to the parking lot is parallel to the other parking spaces.
Time for another proof. The given will be angle 1 is congruent to angle 8. Let's prove that lines J and L are parallel.
Number 1 is of course the given. The second statement would be angle 1 is congruent to angle 4, making the vertical angle theorem, or VAT for short. Number 3 is angle 8 is congruent to angle 4, which is transitive. Lastly, J is parallel to L because congruent corresponding angles give you parallel lines.
Thanks for watching!